Okay, today we're going to move on to 8.4 trapezoids. It's going to have some definitions and some theorems and some examples like our last lectures. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, just like the picture depicts. Bases are the parallel sides, and legs are the non-parallel sides, and base angles are angles touching the same base. So an example would be A and B are base angles. I'm going to draw that right here because they're touching the same base, the top base. And then C and D are another pair of base angles because they're touching the bottom base. And isosceles trapezoid is another definition, which is a trapezoid where the legs are congruent. So that's not always the case, but when the legs are congruent, then it becomes isosceles. All right, here are 3 theorems about the properties of isosceles trapezoids. 8.21, if a trapezoid is isosceles, then each pair of base angles is congruent. So the example here is this picture, and basically if trapezoid FGHJ is isosceles, then angle G is congruent to angle H, and angle F is congruent to angle J. So we can mark that up. G is a base angle with H, so they're congruent, and F is a base angle with J, so those are congruent. Okay, 8.22, if a trapezoid has one pair of congruent base angles, then it's isosceles. Okay, so we can look at this example here and say, if angle L is congruent to angle M, those are base angles to each other. So if they're congruent, then trapezoid KLMP is isosceles, which means that these two legs are going to be congruent as well. So we can get that information just from one set of base angles being congruent to each other. Okay, and then 8.23, a trapezoid is isosceles if and only if its diagonals are congruent. So in this case, here is a picture, and the example is if trapezoid QRST is isosceles, then QS is congruent to RT. Oh no, I'm sorry. If trapezoid QRST is isosceles, oh yeah, that is right. Then QS is congruent to RT. And likewise, if QS is congruent to RT, then trapezoid QRST is isosceles. So those are the diagonals. So if the diagonals are congruent, then it's a isosceles trapezoid, and if it's an isosceles trapezoid, then the diagonals are congruent. Okay, so we're going to do a proof of that theorem right here. So given there's a trapezoid, and it's given that this trapezoid is isosceles, so I'm going to mark it up right here. And I need to prove that AC is congruent to BD, which is the two diagonals are congruent to each other. Okay, so I'm going to start with my given. As always, ABCD is an isosceles. Oh, I spelled that wrong. Trapezoid. Okay, and then that information, actually I need to get rid of this arrow, okay, because it actually only goes to 2 pieces of information from there. So that information tells us that AD is congruent to BC, which I already marked up on the trapezoid. And that's just the definition of an isosceles trapezoid. And then also angle ADC is congruent to angle BCD. That's this big angle and this big angle. And that information is what we wrote earlier in this lecture, that base angles of any trapezoid are congruent. Okay, and then over here we have actually that DC is congruent to itself, and that's an old thing that we learned. Might need to jog your memory about the reflexive property. So that means that DC, this one right here, is congruent to itself at the bottom. Okay, so then if you take those three pieces of information, we can do triangle congruence. Triangle ADC is congruent to triangle BCD, and that's by side, angle side. And then because our two triangles are congruent, we can set two segments congruent to each other. AC is congruent to BD, and that is corresponding parts of congruent triangles are congruent. Okay, so basically we took this triangle right here and set it congruent to this triangle right here. Okay, and then we said that the two diagonals are congruent because of that. All right. All right, example 2. Quadrilateral ABCD has these vertices. Show that ABCD is a trapezoid, then determine whether it is an isosceles trapezoid. Okay, and just a reminder, we need to note that exactly one pair of sides is parallel in a trapezoid. It only can have one pair of parallel sides. Okay, so I am going to plot this. -3, 4, 2, 5 is up here, 3, 3, and -1, 0. Okay. All right, based on my drawing, so I need to prove first that it's a trapezoid, okay? So I need to prove that only one side of parallel lines, one set of lines is parallel to each other and that the other one is not. So remember, parallel, they'll have the same slope. So I am going to, based on my drawing, I think this BC and this AD are going to be parallel, so I'm going to try that one first. So I'm going to do BC. As remember, slope is y2 minus y1 over x2 minus x1. So BC is going to be 3 minus 5 over 3 minus 2, which is -2 over 1, which is a -2. And then we're going to do the same thing with AD. So 0 minus 4 and -1 minus -3 is going to give us -2 over 4. Oh, sorry, -4 over 2, which is -2. Okay, so our two slopes here are the same. So that means there's one set of parallel sides. And we need to prove that the other set is not parallel. Okay, so that AB, we're going to do that one real quick, is 5 minus 4 over 2 minus negative 3, which is 1 over 5. And then DC, which is going to be 3 minus 0 over 3 minus negative 1, which is 3 over 4. And those are, that means that those are not parallel because they're not the same. So this is definitely a trapezoid because it only has one set of parallel sides. So we just proved that. And then the next thing is we have to determine if it's isosceles or not. So go back to the picture. We can see that AB needs to be congruent to DC. So this leg needs to be congruent to that one up there. So we're going to try and prove that. So let's go ahead and find the distance. Remember, distance formula is going to be the square root of the x's squared and the y's squared. So we're going to do the distance between AB, and that is negative 3 minus 2 squared. So the answer here is the square root of 26, okay? And then we're going to do the same for CD. And this is actually the square root of 25, and we can simplify that to 5, but basically we can look at these two square roots and see that they're not the same. So that means AB is not congruent to DC, which means this is not isosceles. But it is a trapezoid, it's just not isosceles. Okay? All right. And then we have some notes on midsegment and then an example, and we'll be done for today. The midsegment of a trapezoid is the segment that connects the midpoints of the legs of a trapezoid. So there's a picture there. There's a line through the middle, and it breaks one leg in half and the other leg in half as well. Okay, so a theorem about the midsegment is that the midsegment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So here's our example here. If BE is the midsegment of trapezoid ACDF, then all these things. AF is parallel to BE, so they're parallel to each other, which also makes it parallel to CD. Okay, and BE is also 1/2 of the two added together, AF plus CD added together. So basically the average of the two, which makes sense because it's going to be a number in between the two. So this is an important equation to remember. Okay, so we have our example down here in the figure. LH is the midsegment of trapezoid FGJK. So we are going to find the value of x. Okay, so go ahead and look at that picture and write it down. In this case, we need to remember that information above, that middle number, that 15, is the average of the top and the bottom base. And it's important that they gave us that it's the mid-segment. That's the only way we can do this, okay? So we're going to start with, LH, which is that mid-segment, equals 1/2 FG plus KJ, and then you need to figure out what you have. So the answer, well, the reason for this is that trapezoid mid-segment theorem we just learned. And then we need to plug in what we know. So we actually do know LH. LH is 15. And we know KJ. So the one we don't know is FG, which is what we're trying to find. And we know KJ is 18.2. And that is just substituting what we know. And then we got to start doing math. We need to multiply. Instead of multiplying by 1/2, we can multiply by 2/1 to both sides. So I'm going to do that in a different color so it's obvious to you guys. Times 2/1 times 2/1. So our answer becomes 30 equals FG plus 18.2. And that's multiply 2 to both sides. And that leaves us with X becomes 11.8, and that was subtracting that 18.2. And if it's just asking for X, then we're done. If it was asking for something else, we need to go plug it in, okay? So X is actually the same as FG. Those are the same values, right? Because X is that segment right there, okay?